Hello everybody and welcome to the second episode of how to create a 2D game in Unity for beginners. In the previous episode we created the base movement mechanics for the character, and in this one we'll integrate the animations along with the running mechanics. Let's go. Let's continue from where we left off. One small thing I've done is I've decreased the zoom of the camera and added a couple of more floors so we can have more space to run around. Basically, you just increase this from 4 to 6, and I just duplicated some floors. Without further ado, let's go into the script. So the main thing that we had before is we get the rigid body, get the input from the horizontal axis, and applied it to the velocity of the rigid body. That's good. The next thing we need to do is we need to work on having the character to move left and right while actually flipping left and right, because right now whenever we move, if you can see, if I go left, he's going left or right, but he's not flipping the character, so it should be going like this, left and then right. So the whole idea is we should look into the axis value, which is either -1 or +1, and then adjust the scale of the object itself. There's a lot of ways of doing this, but one of the simplest ones is to use a boolean and compare it with the current direction value. So let's start with this. We need to create a boolean called facing right, and by default it's true because it's always facing right by default. What we need to do in here, we'll have to do a check. So we have two ways of moving left and right. If we're looking right and we click left, we should flip the character left. If we're looking left and we click right, we should flip him right. So this translates into this. Let's actually write it. If looking right and click left, flip to the left. If looking left and click right, flip to the right. So how does this translate? So if looking right, so it means if facing right, and we look into this value here. Sorry, this one, the direction. So this one always gives us either -1 or +1, which is this thing here. So if we're looking right and we click left, that means the direction should be -1, but we're gonna go with less than 0. If that's so, what we're gonna do is, so we either directly change it, the scale, or we actually save the value and change the x value. So what I would suggest is, I'll just write it and then we see if we can optimize it more. So what we do is we get this vector3, we call it current scale. We have to access transform and local scale. What we do here is we store the current scale value, which is vector3, and by default it's 1 1 1. So we scale it and we save it, and then if we're looking right and then we press left, we have to flip it backwards. So what we do here is we go current scale dot x equals -1, which means it's gonna flip from the right to the left. And at the same time, we're gonna have to change the boolean here. Gonna make it false, so he's not looking right anymore because we flip him to the left. Now let's go to the second one. Else if he's facing left, so there's a couple multiple ways you can do this. So you can either go do it this way, equals false, or you can do this way. You can put that exclamation mark. So this actually means the same thing. It's the opposite. So if we're looking left, which means we're not facing right, and if I click right, which means the direction is 1, which means it's more than 0. What happens here is we change the current scale x value into 1, and the facing right equals true. So that means we bring back the x into the normal state, which is right, and then flip the x. Sorry, we make the facing true. So this is one of the stuff we can do. You can get the scale here, and then you can apply this scale to the transfer the local scale. You can do it this way if you want to have different optimization for it, like instead of getting the value and then resetting it, so we can do just setting it in here once, which can be done like this. So this is one first approach. The second approach is, which I think I like more because you have less lines. The second approach is we actually directly change the vector itself. So right now we have the vector is the whole scale is 1 1 1 1. In the case if we have 1 1 1, like all is one value, this method is really good. But if we have different scales, for example, some objects they have like 1 2 to 1, right? So in this way, in that way, we have to use the other one, in which we're gonna have to get the actual value and change only one specific value. But for this one, we can go with this -1 1 and 1. And we can do the same thing in here. Instead of -1, make it 1. So here we have the moving mechanics and the flipping left and right mechanics. So let's save it. Go back here. And I forgot to actually change this. Let's make it 2 because 1 is really slow. And if we do this, it's falling down. Go right, left. See, everything is really good. So you can notice here the value is -1 because we click left. If I click right, if I keep clicking right, nothing happens. If I click left, it goes left. So right now we have this flipping mechanic is really good. I mean, really important. The next thing what we need to do is have the animation. And to have the animations, you need to get all the sprites for it. Luckily, in this batch of assets, we've got the running animation and the idle. The idle, we're going to use both of them, but sadly we don't have the walking animation. So what I'm going to do is I'm going to use the running animation and I'm going to have them run in a slow pace, which will look like he's walking, and then a higher pace, which will look like he's running. This is simple. So all we have to do is we add an animator component in here, and then we need to create a folder. Make sure to have everything organized, otherwise you're going to have a lot of problems. Let's create an animator controller. Let's call it Fox. This animator controls the animation of whatever game object that we give it. So let's put it here. And then what we can do is, if we click on this object, which holds the animator, and then we need to have two windows open, like the animator window here and the animation window. If you don't see them, just go here, and then you can go into animation. You can get animation animator. It's quite simple. So if we click on the Fox, we go animation. We need to create clips right now. Clips are basically animation states which you can run to exhibit specific animation. So what we're gonna do, let's go animate Fox idle. Let's create the idle animation. In 2D animation, it's quite simple because it's basically a couple of pictures. If we have these images here, whether you have them separate or in an atlas, all you have to do is just drag all of them and drop it inside the animation timeline. By default, it comes really fast. Like if you click play, you can see he's like just working. What you need to do is click Control A, so you can hold all of them, or just drag and drop, and then have this edge stick and drag it as much as you want. Let's give it a try and see how it looks in 1 second. Looks fine. Let's see how it looks in half a second. Actually looks really fast. I think 1 second is good enough. So if we play it, we can see the animation how it looks like here. One idea you have to keep in mind is whenever you create an animation clip, by default it comes, like if you click on it here, this animation controller and this animation clip, it has this moving element in it. It's looping by default, which is good, right? We need this to be looping because it's idle. This is the first thing. What we're going to do, we're going to create the 3 animations, and then we're going to see how to integrate them. Next thing is, if we click on this drop down, click create new clip, we go Fox, walk. We do the same thing, but for us, we have to click here, walk, I misclicked, and we take all these run animations and we put them here. As I said, it's really fast. So what we need to do is we need to move them more, expand them. You can expand the timeline by scrolling down. So we have the walking. Walking means we play the animations in a longer timeline. So it looks like it's slower. So if I put it like 40 milliseconds, looks like he's running. So let's put it in 1.5. See, this one looks much more of a walking thing. Again, this animation is for running, but we don't have the running animation. Walking animation. So we're using the running animation to integrate the walking, which is not a bad thing. It's just you have to create all this stuff. First thing, let me make this guy here. Okay, so we get the walking animation, and again, it's looping, which is good. We don't want to change it to not be looping. Looping is really nice for this stuff. So next thing is we go fox run. We use the same sprites, but for running we have to get it. That one was 120, almost. Sorry, a second and a half. For this one, I think let's try half a second. Okay. I want to have a note here that all the settings that I'm doing for this animation states, it all depends on the walking values. Like here, these values. So right now I have it 2, but we'll get into this in a second. So we made our template for running and walking, right? And if we could click animator, we can see here. Let me just drag this off. So this is the window of the whole animations inside the controller. It's easy to be translated, honestly. It's simply what happens, like you have the entry, the exit, and any state. Entry means whenever the animator is on, what do you want to play? So basically this one cannot be deleted because you have to play an animation. By default it plays idle, okay? That's good. And exit, any state. Any state, it's used for more advanced stuff, like let's say you want to jump, but it doesn't matter which state I am in, I want you to jump, using something. So this one will explore this stuff along the way. What we need to do right now is we need to have something called blend tree, which is here in create state, new blend tree. Blend trees are, let me call it moving, are basically a controller for multiple animations using specific values. We're going to use something called one-dimensional blend tree, which is here. So in the top here place, you can see that we're in a base layer. So if we double click on moving, we get this thing here, right? So we click on the blend tree and we get this motion, which is is empty. So we have to add 3 motions because we have idle, walking, and running. We click this dot here and we choose idle, walking, and running. And we can see from the left side is, let me just minimize this. It got everything set up for us. It shows us that we have the idle, walking, running, because that's how it should be. And we have a value called blend. Blend is basically the controller of all this stuff. Like if you can see here, if we increase the blend, it moves slightly from each value to the other one. We're going to change the blend value to velocity. I'm going to call it X velocity. And what we're going to do is we're going to have to go and test our walking and running animation to see what are the proper values, and we'll get back in here so we can change the threshold here. This one, we have to change this manually. So far we managed to create an animator, animation clips, and then set up a blend tree. Let's get back to the base layer, and what we need to do is we have to take this, put them in here, and then make the transition to the moving. Actually, it's not like this. I have to right click and make this as a default. We have to keep these in here so they're part of the animator, but we're calling the blend tree itself. You can change the name of building tree. You can call it a moving tree or moving animations or whatever you need. Now what we need to do is we need to create running mechanics, which is not that difficult. Let's get back to the script. For the running animations, it's generically known as playing in any platformer game. When you walk with the WASD or the controls, basically WASD, you click shift and it will trigger the faster movement. So we'll use this shift thing right now. So whenever we click shift, as long as we're clicking shift, he's going to be running in a faster pace. If we release the shift button, he's going to go back to the normal speed. So for that, we need to get an input. Alright, so we need to get an input called if input.get key button, the same thing as top button, down, key code dot left shift. So there is this, which means if we click shift, do something. But you can see there's that click down, up, also whenever we release shift, and if we remove this, it's gate key. That means if we keep pressing it. So this one will call all the time. But when we go down, it calls once. We only need it to be called once. And we need to have an indicator. So let's create a boolean called is running. And by default it's false because the shift is not pressed. As soon as we press the shift, let's have it this way, I think. I like it because we only have one line. Is running equals true. Right? That's cool. But we have to do the other thing. Like we have to say if we release the shift button, we have it as false. That's cool. So what we can check right now here is, let's do it serialize. Okay, I can't write properly. Serializable field. So what this does is it keeps my field private, but it shows it in the animator. If you can see here, if I click on the fox, we can see on the right side as soon as it loads. Come on, load. Yep. So we have this is running here. If everything is good, we're gonna be seeing the a tick next to this whenever we click shift. So right now, if I click shift, it's on. I release shift, it's off. And off. You can try this one thing and where I can do the else button here. I want to see if it works because it's really broad to say if it's not clicked. Yeah, it doesn't work because there's a lot of there's key down, there's key, so we can keep it like this. What we're gonna write here is, let's have comments because comments are the best thing. Store the horizontal value. If left shift is clicked, enable is running. If left shift is released, disable is running, which is good. So right now we have an indicator on whether we click the shift or not, which is good. All we need to do is integrate this. So let's actually take this out because we don't need it. What we need to do is we need to actually modify the speed here. We can think of where we do. We can probably do it in here and here, but I'd rather adjusting this value. So what I'm gonna do is we're gonna have to add something called, let's go with float run speed modifier. All right, so again, this value is up to you to do. I'm gonna go with 2, and what I mean by 2 is if is running, we're gonna multiply the x value by running speed modifier. So if we are running, okay, I want to say double because it might have different value. Multiply with the running modifier. So what that means, if the speed is 2, it becomes 4. If it's 4, it becomes 8, and he looks like he's running faster. I made this private because I don't want to make it otherwise. You can make it public, you can make it serializable, it's up to you. So if we go back in here, and then we play the game, let our fox go down. Yep. So right now I'm just moving. But if I click shift, you can see he's moving faster. I release shift, click shift. You can see the difference of the speed. Okay, that's good. So right now we fixed the moving thing. Like we can see the thing happening in front of us, but we need to integrate right now the animations. For that, we have to make a reference for the animator inside the script. Animator. So we have the animator here, and then we have to get it from the same object itself in the awake method, the same thing as the rigid body. So right now we get the animator, right? And then we detect when are we pressing the shift, and then we're changing the speed accordingly. What we need to do is we need to go back here, and we need to look here. We have to change this value according to whatever we want to set here. So, but before we change these values, I want to do this thing where I want to see what's the current walking and running speed that we set. Since we have this as 2, and basically whatever the value is going to double up to become 4, right? But it's not going to be actually 4 because we're multiplying with the time delta time and with 100. So what I'm going to do here, we need to check the x value of the velocity of the rigid body. Alright? So what I'm going to do is I'm going to go debug.log, and we're going to call the rigid body velocity.x. And this way, I'm going to be able to debug the value of the running. Basically, we're going to get plus and minus values, but at least now we can see. Let's give it a test and see what values we get. Right now we have 0, so if we go left, so we have minus 4. Go right, plus 4. Okay, so, but if we're running, we're getting 8. All right. So what we have here is we got these values. So for let's forget about the minus. We get 0 for idle, 4 for walking, and 8 for running. To adjust this stuff, we're gonna have to go to the blend tree here, and then take off the automatic threshold because we have 3 values here. It has this 0, 1, 0.5, sorry, and 1. We're gonna have to change this into something else. So for the idle, if the threshold, that means whenever the value is that, play it. So if we're standing still, it's 0, so it's playing the idle one, which is 0, right? But if we make it 4, it has to go and play the walking. So what we're gonna do is we have to put this value before it reaches 4. So we can go with 3. We're safe here because we're using the raw values, so we're not gonna get 0, 1, 2, 3, 4, right? So we're gonna get, it's gonna increase slightly faster. So we can, if we put 4 here, it's okay. Let's have just 8, 4. So we have 5. So we get the 4 for the walking. I misplaced that, and then 8 for the running, right? So if we go back, play 0, we can see that here. If I click this button here, it's gonna play the whole animation in the bottom right, and we can do a testing from this side here. So if we make this one 4, you can see he's running, he's walking, sorry. Make it 8, he starts to run. I'm a bit skeptic about putting the actual value itself, but let's give it a test. So right now we know these values, and then what we can do is stop this, and then you go back to the scene. Let's go back to the script itself. Of course, let's clear the thing here. So we got the animator, right? We got animator, we reference it. What we need to do is we need to change that value, this one, in the parameters. We can add more parameters if we want. We have different types of float, integer, boolean, and trigger. This one is float. So what we need to do is we're gonna have to go animator.set float, right? And we have to input the name. It's called x velocity. That's cool. But if we go like rb.velocity.x, it's going to input some negative values, but we don't want the negative values. It actually doesn't matter if we're looking left or right. As long as we're just walking or running, we have to play the animation. So there's a cool method in the mathf called absolute. So we get the absolute value of this thing. So if it's minus, it becomes plus. If it's plus, it is plus. So we're going to write here, set the float x velocity according to the velocity to the x value of the rigid body to the velocity. So we have this one here. So since we have this stuff here, let's have this thing as just a reference. What we're doing is we're setting the velocity to this one. So as long as the velocity is 0, we'll send 0, minus 4, plus 4. It's going to be good. So let's give it a test in here. And see. So we played it, going left. So right now I'm just pressing right. So it's walking. So if I click shift, he's gonna run. I wanna mention one thing in here. So right now, because I've set this into 2 and I played with the animation in here in a specific manner, that the speed of the moving object is matching the frames of the animation itself. Like if I increase the walking animation, he's gonna look like he's having a longer strides. So these values, you can play with them around according to your character, and then the whole thing will look nicer as long as you keep on testing. Right now I have them, I mean, they look nice enough. Probably the walking should be slightly slower, but this one will actually demonstrate everything for us. So we have this Foxy running left and right, and it has everything that we need. And with this, we get to the end of our episode, where we learned on how to create running mechanics and integrate the animations for idle, running or walking using the blend tree, and connecting them back to the script to have a proper character that looks left and right and then interacts properly to the input that we give. And I hope you guys like this, and then if you do, please go for the like and subscribe. We're gonna have more interesting videos. And until the next one, bye bye.